Well, hi there, boys and girls. Today we're going to learn the product rule. So let me show you what this looks like. Let's just say I've got some function, h of x, that is defined as the product of two other functions, f and g. And let's say for some reason I'm lazy and I really don't want to multiply f and g together to get this big long thing. Or it might be that it's impossible for me to multiply f and g together. So here is the rule to find the derivative whenever you have two things being multiplied together. And that rule looks like this. It is the first function times the derivative of the second function. And this is our notation for the derivative of the second function, g prime of x, plus the second function times the derivative of the first. And so this is how we are going to be able to find what's called the derivative of a product, or the product rule. Let's go take a look at two applications of this. So here we go. I've got this function that's got, look at that. I got 4 terms in that polynomial, and I've got 3 terms in this polynomial. So I really am not interested in multiplying all of this together and then finding the derivative and then plugging in 1, because that would take me a long time to do. This times this, 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 la 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 la. It's too much. So we're going to take advantage of the product rule. So I've got two functions here. 2x cubed plus 5x squared minus 7x plus 4. I'll basically call that f. And then 4x squared minus 5x plus 2, I'll call that g. So here's how the product rule would work. The derivative would be the first function, 2x cubed plus 5x squared minus 7x plus 4, times the derivative of the second. Now the derivative of the second, with our power rule, we know that's 8x minus 5. And then plus the second function times the derivative of the first. And the derivative of the first function would be 6x squared plus 10x minus 7. So that's the derivative without having to multiply all of that out, which would take me forever and I'd cry. So now we're going to plug in 1, and let's see what our answer is going to be. So if I plug in 1 for all those x's, I'm going to get 2 plus 5 minus 7 plus 4 times 8 minus 5 plus 4 minus 5 plus 2 times 6 plus 10 minus 7. Alright, so let's see what that would be. 2 plus 5 is 7, minus 7 is 0, plus 4 is 4, times 3, plus 4 minus 5, negative 1, plus 2 is 1, times 16 minus 7 is 9. So I get 12 plus 9, and I get 21. Where is that? Right there. So that's an application or an example of the product rule when you really don't feel like multiplying all this stuff out. Now, if you wanted to multiply all that stuff out, then you don't have to worry about the product rule. All right, let's go to the next example. The next example is I've got some function a that's the product of f and g, and I have to find a prime at 4. And I don't have any information about a over here. And I'm supposed to find the derivative of a at 4. So here I'm forced to use the product rule. So let's find out what a prime is. A prime is the first function times the derivative of the second plus the second function times the derivative of the first. And we want to find a prime at 4. So that's going to be f of 4 times g prime of 4 plus g of 4 times f prime of 4. So let's see if we can get that information from this table. So a prime of 4 is, let's see, f of 4 is 14. G prime of 4 is 4. G of 4 is negative 3. And f prime of 4 is 9. So that's going to be, that's a 9 by the way, 14 times 4 is 56, yes, minus 27, so what is that? It's almost 30, it's 29. And so there's our answer, and there you have it. That is the product rule. I will see you tomorrow.